Hey guys, this is Nurul Huda and I am an educator at an online learning app that is Unacademy. There also I am posting videos which are going to be very helpful for you for your CSI net preparation. So if you are enjoying my videos, if you are liking my teaching skills on YouTube, then I hope you will also like my videos on Unacademy as well. So follow me over there so that you don't miss out anything which I am posting there for your preparation of CSI net. So how you have to do this is just download this Unacademy learning app from the app store, and you have to search for my name, that is Nurul Huda, in the search bar, and you will get a screen like this which is shown on your screen right now, and you just have to click on this follow button to follow me over there. All right, and if you follow me, whenever I will upload a new video or anything, you will get notification for that. Secondly, you can also go over there, go to my profile directly from the link given in the description. So that's all for this. Let's continue with the video.
Hey guys, hello everyone and welcome to the channel. So this video is going to be about solid state chemistry, and I was getting a lot of requests from you guys to make video on solid state chemistry. So that's why I will start with this like the most important thing. I'm just going to discuss these things like Bragg's equation, interplanar distance and angle between two planes. And why I'm taking these three things, because see, I have when I saw the previous year question papers and I analyzed them, I found that if you understand, just three formulas are there, just these three formulae, and if you understand the concept behind all these three formulae, then at least one 4 marks question is damn sure. Okay, like last year also, like in June 2018, it was also asked, and from like just like knowing these three formulae, you can easily do one question at least for 4 marks, and if you're lucky enough, you will get like one more question from 2 marks as well. So that's why I have taken this thing. And I would like to get your I would like to ask you people that you can give your suggestions, that whether you want the whole solid state to be covered, then I will try to make that in a course on my Unacademy profile, where I'll be giving all the topics and the questions related to that. So that will be a totally problem solving approach of this solid state chemistry. So if you want that video, so you can tell me in the comment section. So for this video, I will start with this. So we have three formulae, that is Bragg's equation, interplanar distance and angle between two planes. And one more thing, that this video is going to be more specific for those people who are like from non-mathematical background, because I'll be explaining all the little things also. Because like for physical, like for the person who is also always like for the person who is already in touch with physics and like in mathematics, for that person the solid state chemistry is quite easier. But for those who are not from this background, like the person who are from non-mathematical background, for them it is quite difficult to solve, like trigonometry are involved in this, so that becomes quite difficult. So I'll try to explain each and every aspect of it, so please watch this video carefully, and let's start with it. Okay, so we will start from the Bragg's equation. So what this Bragg's equation tells, let's see, what I have drawn with pencil over here, it shows the arrangement of atoms inside a crystal. So in a crystal, the atoms are arranged like in a proper manner. So that's why these are like these are not randomly arranged; these are systematically arranged. Now, what will happen if you like shine X-rays to it? So X-rays will get diffracted from different layers of this crystal, and they will be diffracted in they will be diffracted in a certain manner. So what happens, what I will not go into derivation of this because that is not important. So what happened, this Bragg's, he observed that see, if the distance, interplanar distance, if the distance between the two planes is represented by small d, and lambda is the wavelength of your X-ray which is being shined. So he found that that a beautiful relation, that is 2d and sine theta is equals to n lambda. Now what these things are, I already told you that small d is the distance between two planes, that is called interplanar distance. Then theta is the angle at which this X-ray is falling on the crystal, on the plane of the crystal. Then n is the order. Okay, so order, it depends, in the question it will be mentioned that is it a first order or the second order. So it is first order, second order diffraction pattern. Okay, so what the diagram shows is the first order diffraction pattern, and because it is getting diffracted from the first layer of it. Now lambda is the wavelength of your X-ray which is being shined. So this is a very easy and very simple formula, and with like just using this formula you can do many questions and many problems you can do from CSIR net exam. Now let's talk about the next formula that is on your like the second formula, that is on your interplanar distance. So interplanar distance, that is this small d, this can be calculated by one formula, that is d is equals to a upon under root h square plus k square plus l square. Now what these things are here, a is your unit length, all right. So this is like the length of your unit cell, okay. So this is length of side of unit cell. Like you have a cubical unit cell, so the side of the cube is the length of the side of the cube is your small a, and this h, k and l, this is your Miller indices. So these are your Miller indices. So now I'm not going in that detail that I'll be explaining you Miller indices. I hope you people know about it. So just by knowing the Miller indices and the length of the side of a unit cell, you can easily find out the interplanar distance. And if you find it out, you can calculate other things as well, like the lambda or the theta and all. So this is the second important formula, okay. So this is was the one, and this is the second. Now there is one more formula, that is angle between two planes. So angle between two planes. So now if a crystal is having like more than one plane, and if they are not like if you want to find out the angle between those two planes, the planes will be generally represented by this Miller indices. So how to find it out? The like if you have two Miller indices for the planes corresponding to the certain plane, so you have h1, k1, l1 representing one of the plane, and you have another plane, that is h2, k2 and l2. So you have two planes, and if you want to find out the angle between them, so the formula is that cos theta is equals to h1 h2 plus k1 k2 plus l1 l2 upon under root h1 square plus k1 square plus l1 square, that is square of all these corresponding terms, this is into under root h2 square plus k2 square plus l2 square. So this is the third important formula. So just by knowing these three formulae, 1, 2 and 3, you can solve like at least one 4 marks question you can easily get. So this video is going to be very helpful for those who are not preparing for the physical portion. So you can at least solve one question easily. So now see what you have to know about it. Like you are getting two things, like sine theta you are getting, and you are getting cos theta as well. So how to find out what are the values of different angles? Certain, like some angles are standard and those values are not given in the question. So to find out the value of sine theta, I will tell you a little trick which I have been taught in my class 10th, when I was in class 10th by my mathematics teacher, and I hope you people also know this trick. So for sine theta, you just write the angles like 0 degree, 30 degree, then 45 degree, 60 degree and 90 degree. So these are certain standard angles for which you can find the values easily. Now just write the numbers like I am writing. So 0, 1, 2, 3 and 4. Remember, start with 0 and to 4. Now divide all the numbers with 4. Okay, just divide them with 4 and just take under root of all of them. Now what the values you will get over here, that will correspond to each of the sine value. So 0 divided by any value will give you 0, or under root of 0 is 0. So sine 0 will be your 0. Now for sine 30, if you want to find out, so 1 upon under root of 1 will be 1, and under root of 4 will be 2. So this will give you 1 by 2. Now here this will cancel out, and here we will get 2, and like 1 under root of on the numerator we will get 1, and in denominator we will get root 2. So sine 45 is 1 by root 2. Now for 63 you can't do anything, so you have to write it as root 3, and 4 you can write as 2. So sine 60 is root 3 by 2, and for 90 you can cancel out these things and you will get just 1, and under root of 1 is 1. So sine 90 is 1. Now this is the way to find out the value of sine theta. Now if you want to find out the value of cos theta, now what you have to do, just reverse the order of it. So just write in the reverse order. So this will be 1, this will be root 3 by 2, this will be 1 by root 2, this will be 1 by 2, and this will give you how much? 0. That means cos 0 will be 1, cos 30 will be root 3 by 2, cos 45 will be 1 by root 2, and cos 60 will be 1 by 2, and cos 90 will be 0. So this is like very simple trick to find out the value of sine and cos. At least you can find out the value of sine and cos, so that if required you can use them in here. Okay, so this was all about I wanted to tell you related to the formulae. So these are the formula, and you know what are the different terms. Now let's try to apply this knowledge and try to solve questions from previous years. So I'll be taking like 4-5 questions, and I'll try to take as many questions as I can, and I'll try to make you people understand that how to apply this thing easily. All right, so let's take this question from CSIR June 2016 exam, and this question was quite simple and it was asked for 2 marks. The question says that then in cubic crystal, the plane 1, 0, 0 is equally inclined to the planes. Now you have to tell that this system, this plane, that is 1, 0, 0, Miller indices are given basically. So this plane is equally inclined. That means the angle between this and the corresponding planes should be equal. So you have to find it out. So let's try to do this question. So when you take this, see how many planes are given, how many different planes are there. So this and this are same. That means you have to solve for, I'm just writing over here. So 0, 1, 0, you have to check between this. Then 0, 1, 1, 0, 1, 1 is here also. So 0, 1, 1, for this also you have to check. Then 1, 1, 0 and 1, 1, 0. So they both are same. So 1, 1, 0 you have to check, and 0, 0, 1 you have to check. Okay. So 0, 0, 1. So 0, 0, 1 also you have to check, and one more is there, that is 1, 0, 1. So 1, 0, 1. So you have to check for these 5 and this angle. So as I told you, the formula was cos theta is equals to h1 h2 plus k1 k2 plus l1 l2 upon under root h1 square plus k1 square plus l1 square into under root h2 square plus k2 square plus l2 square. Okay, this is h2. So just put the values. So for the first one, for this and this, h1 will be 1 and h2 will be 0. So just put these values. So I'll just do, so for 0, 1, 0. So for this one we'll solve. So we'll get cos theta is equals to, now 0 into 1. All right, I'm sure you people are getting it. This is h1 and this is h2. So just put the both things. So 1 into 0 plus k1 k2. So k1 is 0 and k2 is 1. So 0 into 1 and plus l1 l2. So 0 into 0. And in denominator you will get square of all these three. So you'll get 1 square plus 0 square plus 0 square into, and the other one will be 0 square plus 1 square plus 0 square. So on solving, in the numerator you will get like 0 here, 0 here, 0 here, and 0 divided by any number will be 0 only. So cos theta will be 0. So for this plane and this plane we have theta, cos theta value is equals to 0. I'm just writing the value of cos theta. Will not go into the value of theta because it is not asked in the question, so no need to do that much work here. Okay, just follow the value of cos theta only. Now for next, that is 0, 1, 1. For this if you'll do, so cos theta will be equal to, so for 0, 1, 1, so h1 h2, so so it will be 1 into 0 plus then 0 into 1, so 0 into 1 and plus 0 into 1. All right, and divided by under root of this thing. So it will be 1 square plus 0 square plus 0 square into under root of 0 square plus 1 square plus 1 square. So in the numerator you are getting 0 into 1, that will be 0 plus 0 and plus 0 again. So that means you are getting 0 in the numerator, and denominator whatever you get, numerator you are getting 0, so that's why you will get 0 as well. So here also you will get 0. So it's not degree. So here also you are getting 0. So that means for this and this, the value of cos theta equal. That means these, for them the like the angle is equally inclined. So in which of the options you are getting these two? So 0, 1, 0 and 0, 1, 1 you are getting in option number 1. So option number 1 becomes your correct option. Now you can check for others as well if you want to check. So just check for this option, that is in the second option, check for this. So if you will take this, so in the numerator you will get 1 into 1, that will be 1, and that is 1 into 1 and plus 0 into 0 plus 0 into 1 upon under root of 1 square plus 0 square plus 0 square, and here you will get 1 square plus 0 square plus 1 square. So in the numerator you will get 1 plus 0 plus 0. So in the numerator overall you will get 1 upon, in the numerator, in the denominator you will get under root 1 into under root 1, that will be 1. So you will be getting 1 in the denominator as well. So you are getting 1 here, not 0. So that means for this it is not equally inclined. So you can check for other options as well, and you can try on your own, and you can find that whether you are getting same or not. Okay, so I'm not going to do further. I'm just going to do the next question. So for this question the correct option was 1. All right, so CSIR June 2016 was a, like in this exam we got two questions from this part. One we already solved for 2 marks, and this question again came for 4 marks. And the question says that for a simple cubic lattice, the ratio between the unit cell length and the separation of two adjacent parallel crystal planes cannot have the value. So see, very simple. This question was very simple. Just the way it is written, many people like they didn't tried this. So the question was very simple. See how it is. What they are saying, that the ratio between unit cell length. So I already told you that unit cell length is nothing but a small a. All right, and the separation between two adjacent parallel crystal planes. So I already show you in the starting only that separation or the distance between two adjacent parallel planes was small d. So they are talking about a and d. So the ratio of a and d, that is a upon d, cannot have the value. So what value you cannot have? Separation of, so the ratio between the cell unit cell length and the separation of two adjacent plane cannot have the value. So which value you cannot have? So we can use this formula. See how simple this question was. D is equals to a upon under root h square plus k square plus l square. This was the formula. Second formula which we like understood in the starting of the video. Now what we have to do, we have to just find the value of a upon d. So bring d here and take this to that side. So what you will get, so you will get a upon d is equals to under root h square plus k square plus l square. Now this h, k and l, all these three are Miller indices, and they can have like the whole number values. That means you can have this value of 0, 1, 2, 3, any values. The values cannot be like these values. You cannot have the value in fractions. Okay, so or in root you cannot have the values in root as well. So now you have to check that which of these values you cannot get. So in order to get 5, how you can get 5? If you get like for h square, if you have value 1, so if you have 1 for square, then for k if you have 2, and for l if you have 0, so how you can easily get like under root 5. See how 2 square will be 4, and 4 plus 1 will be 5. So you will get under root 5 here. So in the under root 5 means 5 to the power 1 by 2. So that's only representing under root 5. Now for 7, how you can get 7 under root 7? See, if you start with the smallest number, so if I take 1 square plus and then 2 square, so 2 square will be 4 plus 1 will be 5, and now I need 2 more mark, means 2 more number, 2 number more. So I cannot give under root 2 square. So there is no way of getting 7 like under root 7. Try of your own. If you can take like 1 square, then also you will get the value of 1 square will be 1, 2 square will be 4, 1 plus 4 plus 1 will give you 6. So under root 6 you will get. And if you take like 0 over here, so you will get under root 5. So there is no way of getting under root 7 as the answer. And for 11, see how you can do. For 11 you can do like take from this smallest, take 1 square plus you can have many ways of doing this. You can take 3 square. 3 square will be 9, plus 1 will 10, and 1 square will give you 11. So this is one of the way of getting 11. For getting 13, see how you will get 13. So just give 1 square plus 1 square, then 2 square, this will be 5, then you need how much, and then 3 square. So 9 plus 5 will give you 14. No, this cannot be the true value. See how you will get. Yeah, you use 3 square, that will give you 9, and 9 plus 4 you need to get 13. So 2 square will give you 4 and plus 0. So 3, 2 and 0, you can have the values of HKL. So that can give you 13. But for getting 7, you don't have any option to get 7. Like you just have to take 3 values from 0 1 2 3 or any of them, so that you can put them in this formula to get under root 7. So it is not possible to get 7 others are possible. I already show you that this by this way you can get like sorry by this way you can get under root 11. All right, and by this way you can get under root 13, under root 13, and by this way you can get under root 5. But to get under root 7 there is no way. So the correct option will be 2, because it has been asked that what that cannot have the value, that which values you cannot have. So under root 7 is the value which you cannot have. All right, let's move on to the next question. Alright, so let's take the next question. That was from CSR December 2015, and this question was asked for 4 marks. And the question says that that for a simple cubic crystal, X-ray diffraction shows intense reflection for angles theta 1 and theta 2. So there are two angles, theta 1 and theta 2. Both of them are showing intense reflection, which are assigned to 101 and 111 planes. So these are the HKL values given for the respective planes. The ratio of sin theta 1 and sin theta 2 is. Now see, this question was also very simple. It was based on Bragg's equation. So they are asking about sin theta 1 and sin theta 2. So where you will get sin theta? So we already solved, like we already discussed in starting that we have 2d sin theta is equals to n lambda. So this was the formula. So if I have let's say 2d sin theta 1, okay, so if I 2d1 sin theta 1 is equals to n lambda. So because the lambda will be same, because we are using the X-rays, so the wavelength will be same and order is also same. For the simple cubic lattice, show intense reflection for the angles theta 1 which are assigned to respectively ratio of sin theta, and so order also we have to take same. So the next one will be how much? 2d2 sin theta 2 is equals to n lambda. Now if I take the ratio of sin theta 1 upon sin theta 2, you have to just divide both of them. Okay, so if I have to divide both of them, so I will write 2d1 sin theta 1 upon 2d2 sin theta 2 is equals to n lambda upon n lambda. So this will be getting the, like these two will be cancelled out and 2 also get cancelled out. Then sin theta 1 upon sin theta 2 will be d2 upon d1. So this is what you get. So this is the ratio of sin theta 1 and sin theta 2. Now how to get these values of d1 and d2? So for this we will use the formula for interplanar distance. So d is equals to a upon under root h square plus k square plus l square. Now since the cubic is same, that is we have the simple cubic only, so value of a will also be same. So just put the values here. So for d2 we'll be having a upon under root h2 square plus k2 square plus l2 square. Okay, so for d2 I am writing it like this, and for d1 I have a upon h1 square plus k1 square plus l1 square. So this a will be cancelled out, and what I will get, okay, so what I will get sin theta 1 upon sin theta 2 is equals to, this will go up, so h1 square plus h1 square plus k1 square plus l1 square under root value and upon under root of h2 square plus k2 square plus l2 square. Just put both of these values. So h1 k1 l1 given in the question is 101. So if I put these values, so what I will get, so in numerator I will get 1 square plus 0 square plus 1 square, and denominator I will get 1 square plus 1 square plus 1 square. So how much will be the answer? In the numerator I will get 1 plus 0 plus 1 will give you 2, so under root 2 upon, in denominator I will get under root 3. So I will get root 2 by root 3. So just solve this and find the correct answer. Okay, so you will get the correct option to be 0.82. Just take the value of root 2 is equals to 1.414, and for root 3 just take value 1.732 and just divide both of them. So obviously the denominator is greater than numerator, so you will not get the value more than 1, so you cannot get option 1 and 2, and option 3 and 4 you have to check. So just divide and check. Okay, so like this you could have done this question for 4 marks in CSIR December 2015. I will take one more question. Okay, so this question was asked in like CSIR December 2017 exam, and this was also asked for 4 marks. The question says that the separation of this is the plane 1 2 3, and these are the Miller indices given on an orthorhombic unit cell is 3.12 nanometer. The separation of 246 and 369 planes are. So see, this question was very simple. It looked some like it is looking difficult, but it's very simple. There are two ways of doing this question. One is the long method, which you should do if you do not understand about like if you are new to this concept, then you should do with the long method, and if you are used to it, then you can use the shortcut method as well. So I'll discuss both of them. So this so they are asking about the separation of this plane in an orthorhombic unit cell is this. So they have already given you the value of D. All right, so D they have already given. So they are asking about this. So for this, what will be the value of D? So we know that D is equals to A upon under root H square plus K square plus K square plus L square. So this is the formula. So if D is already given, that is 3.112 it is given, and value of A we don't know, that is unit cell length we don't know, and for this we have H is equals to 1, K is equals to 2, and L is equals to 3. So how much you will get? 3 square is 9, and plus 1 is equals to 10, and plus 4 will give you 14. So A you will get is equals to 3.12 into under root 14. So this is what you will get the value of A. Now you can put, now you have to find out the separation of this and this and this. So how you have to do, see, so D is equals to, just put the value of, in the place of A, just put 3.12 into under root 14 upon for this plane 2, 4 and 6. How you have to write? 2 square plus 4 square plus 6 square. So just put all these three values. So you will get 3.12 into under root of 14 upon, okay, so if you put these values, so you will get 4 under root of 4 plus 16 and plus 36. So you will get 3.12 into under root 14 upon, here you will get 20, and plus 36 is under root 56. All right, now 56 is your 14 4 ja. So you can also write it in this way, that 3.12 into under root 14 upon how much? Under root 14 into 4, like this. So 4 you can take out from the under root as 2. So you will get 3.12 into under root 14 and upon 2 under root 14. You can write this thing in this way. Now this under root 14 and this under root 14 can be cancelled out, and you will get 3.12 upon 2. So when you will divide it, how much you will get? 2 1 is 2.56. So this is the answer for the first one. So 1.56 for the first one. So obviously in all the options you are just getting this for the option number 1. So option number 1 will become your correct option. So you don't have to solve it further, or for your practice you can solve for the second one, that is you can solve for this plane as well. Just do it in the same way. Just over here in place of 2 4 6, just take 3 6 and 9. So this is the long method. This is the method of, like, this is the normal method of doing this question. Now let's talk about the shortcut method. So if you will see the shortcut method, you will see that for the plane which is given already, that is 1 2 and 3, if you talk about this plane, this is 2 times of 1 2 and 3. So you can write it 2 1 2 and 3. Why? Because if you take out 2 from here, so you will get the same plane, because these are multiples of 2, 1 2 and, like 1 2 and 3 multiplied by 2. And over here, if you'll see, this is 3 times of it. So just take out 3 from here, so you are just getting that thing only, that is 1 2 and 3, and taking out 3 here. So this is 2 times of it. So separation is 2 times. So that means the distance, the interplanar distance for this, what it is given, that will become half of it. So since the plane is becoming 2 times, so the distance will become half of it, so because these are the Miller indices. So as Miller indices are the reciprocal of your intercept on the axis, so they are reciprocal of it. So that means on the axis, the intercept must be half of it. So that's why distance also becomes half of it. So what you have to do, just the value which is given, just divided by 2. So 3.12 divided by 2, that will give you for the first plane. And for the second plane, what you have to do, 3.12 divided by 3, because this is 3 times of it. So just divided by 3. So this is the shortcut method. If you will do by this, so you will get 1.56 over here, and here you will get 1.04. So see how simple this question was. If you know the shortcut method, you would have done this question easily. And if you don't know the shortcut method, then also this question is not that difficult. This is easy also. Okay. So in this way, I have tried to take uh, 4 questions, and I tried to make you people understand that how this concept is so important and very easy as well. So by knowing only these 3 formulas, you can easily get at least 4 marks, and you can get 6 marks as well if you are lucky enough, like it was in December 2016. So one more question was asked in CSIR June 18, and if you want to get the link of that, like if you want to see that how to solve this question, so I'm giving the link for that. So CSIR June 2018 question on solid state based on this Bragg's equation only, that is solved over here. Just go to this link and watch that video also. So that's all for this video, and I hope you people like the video. So one more thing that which I also already discussed in the starting of the video, if you I want you people suggestions of your people, that if you want the whole syllabus, whole course to be covered, then I can cover it on an academy. Otherwise I will like leave this solid state and I will move on to the next topic. So thank you for watching. That's all for this video. Have a great day. Bye bye.